Login acceptance.
There we go. Right. Good afternoon. Welcome. So this session is actually going to be in two parts. So the first half is now, and then the second half, very strangely, is going to be after the break. Because what I'm going to do is I'm going to talk about all the new features that have been added to the Java platform since the last long-term support release, which was JDK 11. So logically, I'm going to go through everything in JDK 12 through to JDK 17. Now, what I'd like to do is to start by asking you, the audience, a couple of questions. So let's talk about which versions of Java you're currently using at the moment. So if you're using, a version in production, then who's using JDK 8? Okay, lots of people. Good. Anybody using JDK 7? Nobody. Good. Anybody using JDK 6? Nobody. Excellent. And I'm guessing then that nobody's using anything older than 6? Good. That's really good, because you do still find some people who are using, older versions. I actually had a customer we were talking to recently who was insisting on using JDK 1.4.2. No, really not a good idea. Okay, so let's move forward a bit. Anybody using JDK 11 production? Okay, good. What about anybody using 12? 13? 14? 15? So same hands going up here, 16? Okay, right. And I'm guessing nobody's using 17 yet because it's early access. Right, well, it's good to see. So realistically, most people or a lot of people are using 8, and there's quite a few people whose hand went up when we talk about 11. So I'm guessing that you're following the long-term support strategy that was introduced by Oracle and has been followed by all of the other providers of OpenJDK distributions. Right, so let's get on with the introduction then. So Java has changed a lot over the last few years. And a large part of that has been because we've moved to this 6-month release cadence. And that seems to have been a really good idea. In the past, we've had anything between 2 and 4 years between major releases of the Java platform. And that has led to sort of quite glacial changes in terms of the language. But it's also led to, very sort of lumpy changes. And by that, I mean, we get a whole load of things delivered, and then we have to wait another 2-3 years before we get another whole load of things delivered. And that's really not the great way to do things. So moving to a 6-month release cadence, I think, has worked really well. And we'll see, certainly as we go through the rest of the presentation, all the things that have been added. And what that's resulted in is 8 releases. I mean, it's hard to believe. 8 releases since JDK 9. And I think that includes JDK 17, so I might be getting a little bit ahead of myself here. And what it really means is that we're getting more features delivered more quickly than we've ever had in the past with Java. I think everybody will agree, certainly after I've finished the presentation, that the pace at which Java is delivering on the things that we as developers need is really quite impressive. And so I do sort of say that Oracle have done an extremely good job of doing that. So as I said, this session is going to explore everything, well, not quite everything, that has been added since JDK 11. And obviously that's to help you get ready for JDK 17, which is the next long-term support release. Okay, brief word about licensing, because this is actually quite important. Now, in the past, Sun Microsystems, who created Java, I was lucky enough to work for them in the day, they provided Java through java.sun.com. And you could go there and you could download it and you could use it for free unless you wanted to put it on an embedded device. And that was what was called the field of use restriction. When Oracle took over, they bought Sun, they followed the same idea and they said that Java, You could use it in your data center, you could use it on your laptop, you could use it on your desktop, and there was no problem with that. You could use it for free. Now, JDK 11, things changed. So what was the Oracle binary code license got changed to the Oracle Technology Network License Agreement. Clearly, some lawyer came up with these names. And these are two very different licenses. So you do need to be aware of this. And it also applies retrospectively to JDK 8, because as of March 2019, April 2019, with update 211 to JDK 8, that also changed in terms of the license. Now, what that license means is that if you have been using Sun's JVM, then Oracle's JDK, you need to think carefully about using it in the future, because now there are only 4 places where you can freely use the Oracle JDK. That's personal use, meaning if you're at home playing Minecraft, that's fine, you can do that. Development use, so running your IDE, developing code, that's all right. And then the only 2 places where you can use the Oracle JDK freely in what we would consider a production environment is either with Oracle-approved applications, meaning their middleware, their applications, or on the Oracle Cloud. If you're using it anywhere else in production, then you actually need to go and buy a Java SE subscription from them. What we've seen since those changes got made is there is now a much wider choice of binary distributions of OpenJDK. And I'll talk a little bit more about one of those, and you'll never guess who it comes from, at the end of the presentation. Okay, now, before we get started on the new features, there's a couple of things we also need to talk about, one of which is Incubator modules. Incubator modules are defined through JEP 11, and JEPs are the way that most of the new features get added to Java now, a JDK enhancement proposal. Anybody who is a committer, has committer status on OpenJDK, can propose a JEP, and it's a way of defining a reasonably sized piece of work that needs to go into the JDK. So JEP 11 is about adding non-final APIs and non-final tools. The idea for this is that you can include things into the JDK, but although they're complete, although they're not beta quality, they're actually ready, they're done, we want to get feedback from developers. We want to find out what they think about these things, so that if there are some things that really need to be changed, or if that API is just really not what developers want, then either those changes could be made before it becomes final, or in the extreme case, they could actually be removed. So an example of that, JDK 9 introduced the support for HTTP 2. So that was an Incubator module, and it became final in JDK 11. We also have what are called preview features. Rather than Incubator modules, which are parts of the API, preview features, again defined through JEP 12 in this case, are about things that apply to the Java language, the JVM itself, or the Java SE APIs. So the Incubator modules are outside of the Java SE standard. Preview features are within part of the standard. So once again, these are not to be considered beta features. It's not like we're trying to develop them in the open. These are features that are fully formed, complete, ready to use. It's just that we want to see what people's feedback is and then possibly make some changes to that. Then, once everything's been done, then we'll see it become a full feature. And we'll see a lot of these as we go through, because most of the things that are being added to Java now are initially added as preview features and then become full features. Now, one of the things that you do need to do, if you want to use those preview features, because they're not part of the standard, you need to explicitly state that you want to use them, so that you're not sort of breaking compatibility with the Java SE standard. In order to do that, when you compile your code, you need to use the enable preview flag, and you need to specify which version of the JDK you want those preview features enabled for. So you can use release 17 or release 14 or whatever. When you run your application, you also need to specify the enable preview flag. You don't need to specify which release it is, because that's already baked into the class files. All you need to do is say, yep, I really do want to use those preview features, and then they're going to be made available. Preview APIs, like I say, some of these things may kind of sneak into the Java SE space, and we'll see a couple of examples of that as we go through. So these are things that are in the Java or JavaX namespace. Right, so let's start very logically with JDK 12 and see what things we've got there. Well, first of those is a preview feature, and this is what are called switch expressions. Now, if you look at the history of the Java language, right from the very beginning, the syntax was heavily based on the idea of the C language. And one of the things that you had in C programming was the switch statement. What that allowed you to do was a sort of multi-if-then-else type of construct, where you could switch on something, and then depending on what the value was, do something else. That's really good, but there are some sort of rough edges around that. The syntax that you use can be a little bit clunky in certain cases. Cases statement, yes. So it can be a little bit clunky in certain situations. So the first thing is that every case or block of cases needs to be set, or every case statement needs to be separated. So you have to have case A, case B, case C. The next thing that you need to remember, well, at least you need to think to remember, is to put a break statement in each of those blocks. If you don't put a break statement in each of those blocks, the syntax is that you automatically fall through into the next one. Now, there are some kind of weird situations where that actually makes sense, but most of the time, you don't really want to do that. So really, you just want to say, for every block of case statements, you want to put a break so that you don't automatically fall through. I know that I have definitely made that mistake in the past. So I've left out the break statement. Suddenly, I've fallen through to the next set of case statements. Something's happened. It's a very difficult bug to find when you're not expecting that thing to happen. The other thing that can be difficult is in terms of the scope of local variables in certain situations isn't always intuitive. So these are the problems with the switch statement. So what we now have in JDK 12 is a new way of doing this. So if we look at how the case statement used to work, this is a very common type of programming idiom. What we do is we want to switch on a particular value, in this case, a day, and then for each value of that, we want to assign something to another variable, the number of letters. Obviously, the code here is very simple. We've got case Monday, case Friday, case Sunday, assign number of letters to be 4, case Tuesday, number of letters 7, and so on. That's all very good, but as I say, you look at that, and there's a lot of code there. You know, we've got each day of the week separated out on a line, so case Monday, case Friday, case Sunday. We have to remember our break statement, otherwise we'll drop through. And we also have to remember, for each of those situations, we need to make the assignment to the number of letters. And again, if we forget to do that, we can end up with very unpredictable behavior, and we can end up with a bug that's quite difficult to actually find. So lots of lines of code and several situations that make it rather prone to errors. In JDK 12, we now have the new style switch expression. Difference between a statement and an expression is an expression generates a result. The result can then be assigned to a variable. With a statement, you're just executing something, but you're not returning a result. So now the switch expression generates a result, and we can do our assignment once. So that immediately eliminates that potential problem with our code. Because we're making that assignment once, we don't have to remember it for every set of case statements. So that's good. So now we've got switch on day, and we can see that the code is a lot simpler, but doesn't lose the readability. So the first thing we've got here is the idea that rather than having case Monday, case Friday, case Sunday, the developers of this have looked around and they've discovered this incredibly powerful feature called a comma-separated list. And so what they've been able to do is say case Monday, comma, Friday, comma, Sunday. Can you believe it took 25 years to figure that out? I mean, really, surely somebody should have seen that earlier. But anyway, so we have all of our case labels on a single line now, which is good. And then they borrowed some of the syntax from the lambda expression and said, OK, we'll use the arrow as our operator. And on the right-hand side of the arrow, that's going to be the value that we return from the switch expression. So in the case of Monday, Friday, Sunday at 6, Tuesday at 7, and so on. And obviously, if we need to, we can throw an exception. In the case of the default, that's no problem. Suddenly, as I say, that becomes a lot shorter, a lot easier to read, and we don't lose any of the power of the language by doing that. Now, one of the things they did was they also said that you could combine the old style with the new style. So we've still got a switch expression. We can still return a result from each of the case blocks, but we can stick with the old syntax of having a separate case on each line. To do that, obviously we've got the colon involved, and we're not using the arrow. So now we need to have a different way of indicating which value is going to be returned. And they decided to do that using break. So we now have break 6, break 7. Now that will work because break, in this case, is being used in a rather overloaded way. Break, you could obviously break from within the case statement, which wouldn't have a value associated with it, but you can also use break from within a loop, and you can break to a label. So the good thing about that is that if you think about the way that a label is defined in Java, you can't start a label with a number. So it uses the same restrictions as variable names. Just out of interest, because I was thinking about this when I did the presentation, putting it together. Anybody ever used break with a label? Okay, one or two people. I must admit, I mean, I don't know if that's really bad. It's just that I've never actually used it. I've never found a situation where I needed it. I'm sure there are places where it does work, but it doesn't strike me as something that's very common. Anyway, so they use break for that. They also allow you to use code blocks. And so if you want to, you can use the arrow operator, and then you can specify a block of code to execute multiple instructions. Now, the important thing about this is that, as I've highlighted here, you can see that the variable x is highlighted in red, and we can use x in both of those cases. That is a difference to the way that the case statement, the expression switch statement worked before. So previously, you couldn't have used x in both of those cases because the scope wouldn't have worked. Now, within this, it works quite happily. So that's another kind of useful thing from that point of view. But obviously, we have to remember to put break in as well, and we have to break with the value that we want to return. Okay, JDK 12 also had a couple of other things. That was the big sort of language feature. In streams very powerful, introduced back in JDK 8 along with lambda expressions, and there have been a couple of kind of changes along the way. JDK 12 introduced the idea of a new collector, and this collector is called teeing. Teeing takes 3 arguments. The first 2 of those are collectors, and the third one is a by function. And essentially what you're using that to do is to take 2 streams, pass them through a function, and then generate a result. And I've kind of shown that in a diagram because it makes it easier to understand what's going on. The 2 collectors that you define as the parameters to teeing, what happens is that you take the input stream and you duplicate that. So the same input stream is provided to both of those collectors. The results of those collectors is then provided as input to the by function. The by function needs 2 inputs. By function does something with it and then returns a result. Now, the easiest way to understand that is to look at an example. So what we can do here is we can say, okay, we take a stream of numbers, 145, 217, pass that into collect, and then we'll use this new teeing collector. And what we'll do is we'll say that the first collector we want to use is going to take all the numbers on that input stream and add them up. So we'll use summing double of the elements on the input stream. The second collector is simply going to count how many elements we have on that input stream. Remember, it's the same input stream, so we've got a total and we've got a count of how many elements there are. We then pass those into our by function, and the by function simply divides the sum by the number of elements in the stream, and it gives us our average of the values. Now, I know I could have done that with a single method call, but it's more about illustrating what you can actually do with the T and collector. So you can do more complex things than just calculate the average. But that's the basic idea behind what you can do with that. Okay, so that's JDK 12. Now moving on to JDK 13. Text blocks. This is another preview feature. And like I say, most of the features that are being added to Java now are always going to be preview features. In the past, we've had strings in Java, string literals, and we've been able to use those extensively through the history of Java. The problem is that it's always been very difficult if you wanted to construct a string which had new lines in it, and if it had special characters in it, because you had to use escape sequences, you had to potentially concatenate a number of strings, and it just was difficult if you wanted to have something other than just a single line string with text in it. In JDK 13, we now have the introduction of text blocks. And the syntax here, as you can see, I think they might have borrowed it from Python, because it uses the same 3 double quotes to indicate the start of a text block. Everything after those 3 double quotes, up to the next 3 double quotes, is considered part of the string. That includes new lines, it includes any special characters, anything like that. There might be situations where you want to include 3 double quotes in your string. So in that case, what you need to do is you do need to put a backslash before at least the first of those 3 double quotes. Bizarrely, you can put one in front of the first one, you can put it in front of the first and second one, or the first, second, and third one. It doesn't make any difference, but you need to at least put a backslash in front of the first one. Now, if we look at what that actually prints out, what we will see is some HTML tags. And very nicely, we maintain the indentation of the HTML tags that we would expect. But you might look at that and think, well, hang on, why am I printing that out so it's fully left justified in terms of those tags? So the opening HTML tag is right over on the left margin, even though in the text block that I've created, it's actually somewhere in the middle of the screen. And the reason for that is that if you were to kind of take the idea that any white space is going to be included in the line, then we'd have to do everything left justified. And that doesn't really look very nice in terms of the layout of our source code. So what they decided in this particular case is that if you use the opening 3 double quotes and then put text underneath that, what you end up with is what's called incidental white space. So incidental white space is everything up to the first character in your text block. And that will be stripped out for each line. So we're not stripping out all the white space at the beginning, because clearly we need the indentation of those tags to maintain what we've got. But we do allow it to be moved over to the right-hand side so that we get nicer layout for the text in our source code. There are a couple of things to note about this. So the first is that the opening of the text block is 3 double quotes, but it also has to have a new line after it. So it's a little subtle thing there, but you can't put your HTML opening tag straight after the 3 double quotes on the same line. That won't compile. So you have to have a new line, and then, like I say, the indentation of that will dictate, or the indentation of the text will dictate how much incidental white space is going to be removed. Now, the other thing that I've done here is I've deliberately put some extra white space after the closing HTML tag. And so I can illustrate that by moving the closing 3 double quotes over to show that. And what you'll find is that any of that trailing white space will automatically be stripped out. I'm not quite sure why they do that, but they do. So it's just worth bearing in mind that white space on the right-hand side is automatically stripped out. What we can do is, if we actually do want some more padding on the left-hand side, so we want to move things over further, then we can realign where the closing 3 double quotes go. So you put the 3 double quotes on the next line, shift it over a bit to the left, and then what that will do is introduce some intentional indentation. So now we've got our 4 characters spaces of intentional indentation, and we've reduced the amount of incidental white space. So you've got quite a lot of control over this, but there's some subtle things that you need to remember with this. And then if we print out what that gives us, what we'll find is that we see our HTML tags with the indentation that we expect, but we've added that intentional indentation in terms of the white space on the left. But we've also got an extra thing that we didn't really want, which is an extra blank line. And so if we want that additional indentation, we get an extra blank line. I'll come back to that later on. Switch expression. Hang on, I've already talked about switch expression, so why have I come back to talk about it again? Well, this is a perfect example of how preview features work, because when they said that you could combine the old style syntax with the new style syntax, they said, let's use break as the way of indicating what value we want to return from the switch expression. And people said, yeah, not really liking that, because although a label can't start with a number, it could be a bit confusing if you've got a break with a label and a break with a number, and it could just get messy. So the developers looked at that and they said, you know what, you're right, so let's not use break. We'll make a change and we'll now use yield. Not sure if that's the best word, but this is one of those things where if you talk to Brian Gertz about this, he always goes on about bike shedding. If you ever heard about this, it's having massive discussions about what color to paint the bike shed, when what you really want to be talking about is how big is the bike shed, how many bicycles can you get in there and everything. So it's that attention to the tiny details that sometimes gets a little bit out of control. But anyway, what they've done is they decided to change from using break as the way of indicating the value to return to using yield to indicate the value that's going to be returned. So that's a good thing there. Right, so now we move on to JDK-14. Now, JDK-14, I think, was a very good release. It had quite a lot of things in it in terms of new features. JDK-14, if we look at Java again, and we take a very simple example of a data class, what we've got here is a point. Now, point is just going to have two values, x and y. So essentially, it's a tuple. Sadly, Java does not have a tuple class. I always thought that it should do, and it's kind of been a bit of an annoyance to me. And again, I kind of mentioned this to Brian Gertz, and Brian Gertz says, well, if we have a tuple, then we need a triple, and then we need a quadruple, and then how far do you go with defining these classes? And you end up with, 10s and 12s and things like that. So the decision was made not to add a simple tuple class to Java. Right. So what we end up with is code like this. Our point, which has two values. To do that, we create a new class called point. We have to define two instance variables, which are going to be doubles. We'll make them final. Then we need a constructor, which we pass two values to, double x, double y. We have to assign the values from the parameters to the instance fields. And then we need accessor methods so that we can retrieve the value of them, because we're doing proper object-oriented programming and we don't just make them public. So now we need a public double x that returns x and a public double y that returns y. What that means is we've got 14 lines of code for a simple tuple. And if we're doing lots of different things like that in our code, we end up with type pollution, in the sense we get lots and lots of extra classes and lots of extra code, and it just it's not really ideal. So in JDK-14, we now have records. Records in JDK-14 is a preview feature, again, meaning that things can change. How does this work? Well, in its simplest form, if we look at the equivalent to the slide we had previously, our 14 lines of code, that is reduced to a single line, and a single simple line. We now use the record keyword, and we say record rather than class, and we'll call it point, logically. And rather than having to define everything in the body of the record, all we do is we use the same brackets as we would for the constructor, and specify that the values that we want associated with that record are going to be a double called x and a double called y. Empty set of braces, because we don't want any additional logic in there, we don't want any other methods. All we want is something that's going to be able to store two values, x and y, and then return them to us. What the compiler will generate for us there is essentially the same code that we just saw. So we will have a constructor that we can call, pass the parameters to it, create a record with those values, and then we can retrieve the values from it using the accessor methods. Lots of details about records. So for start, records are immutable in the sense that all of the values that you create for them are going to be final. You can't have ones that are going to be changeable. There's no mutability in terms of the elements that you put inside the record. Obviously, that doesn't extend below that. So if you pass in an object as one of the elements or one of the parts of your record, although you can't change the reference to the object, you can change the things that are in that object. So you can call methods on it and do things like that. But the immutability is at the level of the record itself. You can make records generic if you want to. And the reason for this is that really a record is just a special form of class. So class can be generic, so a record can be generic. And you could do something like this. You could have anything, you can specify a type parameter t, and then you can say that the value that you want associated with this record is of type t. And that means you could store anything you want in there, any object reference, it'll work. Now, if you want to, you can add instance fields, but only if they are static. You cannot add instance fields that are not defined in the record definition. So in our point, we've defined $X and $Y. We couldn't then, within the body of that record, have another instance field called Z. But we can have static instance values. So in this case, I've created something called a circle. It's going to have a value that's associated with that called radius. Within the body of my record, I'm going to have a bit of extra logic. So first of all, I'm going to create this static final double pi, and that will work because it's a static one. And then I'm going to provide another method, so extra business logic, in terms of being able to return the area. So that will use the value of pi multiplied by the... Yeah, I should have actually done radius squared, shouldn't I? Pi r squared is the area, not pi r. Yes, my son will have a go at me about this. He's doing like exams in maths at the moment. Anyway, so yeah, you can calculate the area using that static variable. You can add a method if you want to. So that will all work. Some additional details about records. As I said, records are just a special form of class, in the same way that enumerations are a special form of class. The base class of records is java.lang.record. What that means, because it already inherits from Java lang record, you cannot subclass from another class for a record. So you cannot create a record which is an extension of another class, because it already extends record, so you're not able to do that with a different class. However, because we can have interfaces, and we do have multiple inheritance of types in Java, then what we can do is we can say we can have a record which implements other interfaces, and we can provide the methods within the body of the record, and that will all work quite happily. So record is the superclass of records. Because it's an object, a subclass of object ultimately, you can override the usual methods. You can override the equals method, you can override the hashcode method, and you can override the toString method if you want to. Those can all be specified in the body of the record. Records are implicitly final. So even though it's not, in the examples I've shown you, I haven't stated that they're final, they are implicitly final, meaning that you can't then extend them further. So you can't inherit from a class, you can't extend them, so they're kind of fixed. A special form of class. If you wanted to, you could actually specify final as the modifier for your record, but it's redundant because it's already implicit, so there's no real point. But it won't cause a compiler error, should you really want to do it. This is quite a big one. Records do not follow the Java bean pattern. Now, the Java bean pattern means that in terms of the accessor methods, you typically use get followed by the name of the variable. So it would be get x, get y in the example that I showed you of the point. Instead, the decision was made just to use the name of the variable rather than get, followed by the name of the variable. So we have x and we have y. That is one of those things that a lot of people will argue, 50 people will argue one way, 50 people will argue the other way as to which is more beneficial. The real point about why this is more of something that you need to consider is that certain frameworks do like the idea of the bean pattern. So they look for accessor methods that are get X and get Y. Some of the things like JPA and Hibernate and things like that, and Spring use this kind of approach. That's not too much of a problem because most of these frameworks now have adapted to the fact that records doesn't use the bean pattern, so you can use records with them. But one of the things you need to consider is you might want to, or you might need to use a more modern version or up-to-date version of that framework in order to get around the issue of that. If you don't want to do that, there is a kind of sneaky way of getting around it, which is to create a record called point, and then you call the variable get X and the variable called get Y, which means you end up with an accessor method called get X and get Y. I was quite, because I didn't spot that one. That was I saw a tweet from somebody who did that. It was like, yeah, that's quite clever. I like that. Brian Gertz didn't. Right, record constructors. Okay, so we already saw that we can have a record without any constructor. So if we just define our point, we don't need to put a constructor in there because the compiler will create the one automatically for us that takes the parameters, which are the elements of the record. But we can do some other things. So there is what's called the canonical constructor. And the canonical constructor is essentially the same constructor that would be created by the compiler. In the case of our record here called trex, we've got int x and int y. We can specify a constructor, and we can say public trex, int x and int y. So we have to specify all of the same constructor details that we would have to before. But then what we want to do is actually have some additional logic in there. So we can have an if statement say, well, if x is less than y, okay, we've got inverted values, we need to print a message. But then we have to explicitly include the code that we would need in terms of that constructor. So we have to have the line this.x equals x, this.y equals y. So at that point, you kind of look at that and go, that's really kind of losing some of the benefits of records, because a lot of the code that was going to be automatically created is now, I'm going to have to write it myself. Okay, I don't have to put the accessor methods in there, but a lot of what I would have done is back in there. So rather than doing that, you can use what's called the compact constructor. So the compact constructor will allow you to do the same thing, but with less code. So now, in our example here, we've got range, which is taking two values, low and high, and rather than specifying the canonical constructor with the parameters in brackets, which is the same as the definition of the record above, we can leave that out. So now we just get public range, no parameters, open brace. We can put in our additional logic to see whether low is greater than high, and if it is, we can do something with that. And we don't have to explicitly set the values of the instance fields. So the compiler will do that for us. So that's a nice way, if you just want to add a little bit of business logic to the constructor, use the compact constructor and everything will work very nicely. However, there is a bit of a limitation with both the canonical constructor and the compact constructor. And in the second example here, I have thrown an illegal argument exception. I am restricted in both of the cases there that the compact constructor and the canonical constructor, I cannot throw a checked exception from those because there is no syntax, valid syntax, in either of those to add a throws clause to the definition of the constructor. So I can only throw an unchecked exception. If I want to throw a checked exception, can't do it that way. A little bit more about constructors again. So in this case, if I did want to throw a checked exception, I could do it this way. And again, this is a little bit sort of cheeky way of doing it, which is to say, okay, I create a constructor, which in this case takes an additional argument, z, and then allows me to throw a checked exception. So I can specify throws with that because I can define a normal constructor with that, and that will work. I have to remember to put in the call to the superclass constructor. Well, it is not the superclass constructor, sorry. It's the constructor of the record. So I have to call the canonical constructor in order for this to work properly. So I call this x comma y, and then I can have if x less than y, throw new checked exception. So it's the important thing here is that the constructor signature must be different to the canonical one. So as long as I add some extra variable in there, I can do this. But again, that's being a little bit cheeky because I'm ignoring Z and I'm not using it. And it's probably a bit too messy. If you're doing things like this, records probably aren't the right thing to use. Let's say that. And then finally, the records default constructor. So you can, if you want to, include a default constructor. So in the case of our T-Rex, we can just specify T-Rex without any arguments, and we then call the canonical constructor with some specific arguments, and that will all work. So we have to do that. Okay, so next thing in JDK, let's see, where are we? 13. JDK 13, instance of. Again, if we look at the history of Java, we've had instance of right from the very beginning. And the idea behind this was to enable you to pass an object reference to a method where you didn't know the specific type of it. So you could pass in an object or you could pass in a superclass, but what you wanted to be able to do is identify which specific subtype it was. And to do that, you would do something like this. You would say if obj instance of string. If it is an instance of string, then the first thing you have to do if you actually want to use that reference, which I'm guessing you probably do if I've identified it as a string, then you have to do an assignment to a variable of type string, and you have to do an explicit cast of object to string. That's great. Now you have string s, and then you can call the string methods on that, and it will all work quite happily. Problem is that that's basically what you do every single time. So we've kind of ended up with a little bit of extra boilerplate code that we might not want to have every single time. In JDK 14, we're on 14, aren't we? Yes. JDK 14, we introduced the idea of pattern matching for instance of, another preview feature. Now, first thing to understand here is when we talk about pattern matching, we're not talking about like regular expression pattern matching. This is pattern matching in terms of types. So matching a type and then doing something with that. In this case, what we do is we simplify the code that we had previously. We can now say if obj instance of string, which is the pattern that we're looking for, is it an instance of string, then what we're going to do is assign that to a variable called s. So all we do is we specify s after the string. Great. So now we don't have to do the explicit cast. We don't have to assign create an instance variable because it's already in the test in the if statement. What we can then do is in the true branch of that if statement, because we have got a string, the scope of s is valid, so we can call the methods on that and we can look at the length of it and so on. In the else branch, clearly we don't have a string, so the scope of s does not extend to there. It won't be valid, so we can't call s and it won't work. So that simplifies our code. What we can do is we can be a little bit more sophisticated. So we can actually say if obj instance of string s, and then we can add an additional test. We can put an ampersand in there, 2 ampersands in there, and say if obj instance of string s and s.length is greater than 0, then do something. This will work because if you look at the AND operator, we know that the left-hand side has to be evaluated first and must evaluate to true before we try and evaluate the right-hand side. We know, therefore, that obj must be an instance of string, and so the scope of s is valid on the other side of the AND operator. That way we can call length on it, we can test it, and that will all work, and we can continue with our code. If we were to try this, it wouldn't work, because if we try using OR, then the Boolean logic falls over, we evaluate the left-hand side, and in fact, we would only bother evaluating the right-hand side if the left-hand side evaluated to false. So you guarantee that S wouldn't be valid if you got to the point where you were trying to test against it. The compiler will recognize this. The compiler will say, nope, that's an error because S may not be valid in terms of its scope, and you won't be able to compile it. So what happens here is that they use what's called flow scoping. And sometimes you need to be a little bit careful about how that works, because you can end up with things like this, where we say, if O is an instance of string S and s.length is greater than 3, but then we'll invert that, so we'll use a not, then we're going to return. So in that case, we know that we've returned because we don't have a string. At that point, S is still valid, because we've effectively got the else part below that, because we've done the test, that failed, therefore we can drop below there, and so S is valid for the rest of that method. Just be a little bit careful with that. Also need to be a little bit careful in terms of the way that the scoping works, because you can get overloaded scope and hidden scope. In this case, what we've got is a class where I've defined a string called S, which has a value of 1. Then I've got a method called testMyObject. I pass in object O. I do the test using instance of, and then string S. And then within the body of that, obviously my S reference is going to be to the variable which is a cast of O to a string. So now I'm actually, when I talk about S here, I'm talking about the value of O, not the value of S, which is the class instance variable above. So when we print out string S, what we're getting is whatever the value of O is, and then if we do something and manipulate that, let's concatenate 2 onto it, we're actually modifying the pattern variable, not the class variable. And then once we drop out of that if statement, because the scope of S now disappears for the pattern variable, we're now back to the class variable, and when we print out S, we'll print out 1. So we haven't changed anything, and So again, if you're doing this, you're definitely doing something wrong with your naming scheme. So I wouldn't recommend that, but it's worth just bearing that in mind. Okay, text blocks. So again, this was a preview feature, remember. Now it's a second preview feature. And again, a couple of things were changed in terms of making it better. What they did was they added 2 new escape sequences. First of those is just simply a backslash at the end of the line. Now, if you've done makefiles or shell scripting, then this is going to be familiar to you. Essentially means don't put a new line in here, just continue the string as if it was on the same line. So it allows you to add or remove the new lines and make your text longer. The other thing they did was to add \s, which solves the problem of the trailing spaces. So if you do really want trailing spaces after your text, then you can put trailing spaces followed by a \s, and they won't get stripped out. The other thing with the backslash is that you can solve that problem of the extra blank line that we saw earlier. Again, this is a great way of demonstrating how useful the idea of preview features is, because people went, oh, hang on, what about that extra blank line? Hang on, I want some space after my text. And so they addressed that with the text blocks preview. Okay, so I'm actually almost out of time in this session. So I think rather than getting into the foreign memory access API, I'm going to stop here. We're going to have a break. And then if you want to come back for the second half of the session, we'll go through the rest of JDK 14, 15, 16, and 17 in the remaining 50 minutes that I've got after the break. So if anybody's got any questions, please feel free to come and ask me. Otherwise, you get an extra minute and a half for your break. Thank you.